In this video, we're going to teach you how to convert one of your existing designs into a subcomponent, just like the box over there for the hexadecimal keyboard, so you can reuse them in different places, as well as in future lectures. This particular concept concerns designing your own subcomponents or functional blocks. The basic idea is, for example, if you actually want to use the 7-segment display decoder in one of your other designs, it would be very impractical to draw a complex circuit like this every single time. Instead, what you can do is you can essentially make all of this entire piece into a single small little block, and then you can plug it in and use it elsewhere. To be able to do that, first of all, make sure you have a working example of your circuit like this. Right now, as you can see, this is exactly the same circuit as we've shown you from the previous example. It is fully working. It is displaying the correct numbers for input 0 all the way to 9. The next thing we're going to do, we're going to replace all of the input and output ports. Let's go to Libraries and go to pseudo devices. Inside pseudo devices, you'll be able to find something called port in and port out. These will be what we're going to be using to create this particular circuit. The first thing you'll do is you will replace all of the inputs. Right now we have a hexadecimal keyboard as input. We will delete it and replace them with port ins. Make sure you check your connections. And then what you will need to do in this particular case, you will need to click the ports, not the wires now. You will need to click the port and then right click and give them names. This is what you would do if you want to name your ports from A to D. In this particular case, because the input is a number, what I'm going to do instead is to start calling it D sub 3, D sub 2, D sub 1, and then D sub 0. The idea is the variable D over here represents a single number, and the most significant digit will be the one with the most significant number. So D sub 3 is the most significant digit in your input, and 0 the least significant. On the output side, we will need to use port out. We drag out port out and then flip it horizontally so that it's facing the right direction. And we can get rid of this display as well as the ground unit. Once we have created all of the port outs, we will also need to give them names. Again, you will need to select not the wire, but the individual port outs. Right click, name, and let's give them the ISO standard names. Lowercase a, b, c, d, e, f, G. Once you've done that, again, you need to save the circuit to somewhere you can remember. And then what you will need to do is you will need to go to File, select New, and instead of selecting a new circuit, you will need to go to and select Device Symbol. Click OK, and this will actually bring you to a completely different drawing board. You'll be able to identify this by looking at the tiny little icons on the bottom over here. For a circuit, its name is going to end with CCT, and it's going to have a icon that kind of looks like a tiny little chip and an AND gate. in this particular case, we are actually dealing with the diagram of a part. So it looks just like a tiny little chip over here. And you'll find a set of new tools at your disposal. On the left hand side, you have an empty slot over here. This one we don't need to care. This one we do need. This one contains a list of all of the pins. Right now it should be empty and the name should be part 1 or part 2 or something. The next thing you need to do is to create connection between your circuit drawing, this particular thing, and the part diagram. What we need to do is to go to Options, Sub-Circuit and Part Type. In the Primitive Type tab, select Create a Sub-Circuit symbol and select an open circuit to attach to it. It will prompt you to select one of the opened circuits. Let's select the circuit that we just draw over there. Click OK. Click Done. Once you've done that, you should be able to see all of the ports you've defined, all of the inputs, all of the outputs from circuit1.cct. The next thing is you can use the drawing tools. I'm going to draw just a standard rectangle like this. And I'm going to use the pin tools to draw all of the pins. Let's first deal with the inputs. So the order that the pins will appear is the same order that it appears on this list. So the first pin you're going to insert is going to be D3. Let's do D3, D2, D1, and D0. What I always like to do is always make sure the most significant digit is on top and the input is always on the left. And the other thing you should also pay attention to is to make sure the spacing between two pins are the same. So this is completely overlapped. This is 1 spacing. This is 2. I usually leave it at 2. And then let's deal with the output. A, B, C, D, E, F, G. Let's select the pin towards the east. A, B, C, D, E, F, G. Once you're done, also it's a good practice to give your component a name on the diagram. So let's drag all of this out to the right a little bit and then use the text box to give it a name. This is BCD 27SIG. Let's try to make it look pretty. It's not always easy to make things pretty in LogicWorks, but we try our best. That looks okay. The next thing you should do is you should try to save this. Go to File, go to Save, and as you can see, this one is going to prompt you to do something a little bit different. So what we're going to do is we're going to open Library, click the button, and then try to save your library file somewhere safe, somewhere you can remember. And for me, this is going to be inside my documents, and I do have a folder called LogicWorks. And I'm going to save it inside CSCI150.clf. I'm going to save this part as 7 segment. Sorry, BCD to 7SIG decoder. I click Save, and then once I go back to create a new circuit, I can find this device inside my library. This device will appear inside my own library as BCD to 7 segment display. I can drag it out, and then I can verify that it actually works by plugging in a 7 segment display like that. Again, make sure A is aligned to A, so let's flip it vertically. Plug it in and get a hexadecimal keyboard without SDB. We don't need that. And as you can see, it will work right out the box. So you don't have to reinvent the wheel every time you want to use the BCD to 7-segment display decoder. Now it is also very important that you try to open your library whenever you reopen LogicWork. Say for next time you locate your library, open it, and then you'll have instant access to all of your previous components. Otherwise, your library is not going to be there. It's not going to be loaded automatically. You will also note that in some of the future labs, I will require you to also submit your library file. So this is actually the library file we are referring to. Thank you.